Good evening, Titans. This is Mr. Sturts. We are on lesson 9.1. We're going to do the second section of this video. All this video is going to contain is performing operations with radicals. We're going to add and subtract radicals here. So open up your student journal. I know you already took notes in there, so if you don't have room, maybe use another sheet of notebook paper. Make sure we just get these examples down so when you come to class tomorrow, we're a little better prepared. All right, our main concept is when we have radicals with the same index and radicand, they are called like radicals. Okay, let's talk about what that means. If we think about a radical here, and let's say we have a 5 underneath. What that 5 is what we call the radicand. It's the number underneath our radical. Now the index is just the number out front. So if we're working with a cube root, our index is 3. All right, so if we have the same index, same radicand, we have what we call like radicals. When this is the case, we can add and subtract like radicals. So let's do an example. Let's say we have 2 cube roots of 5 plus 3 cube roots of 5. Okay, we have the same index, we have the same radicand in both of those, so we can just add our like terms. If we have 2 cube roots of 5 and we add 3 of them to it, we end up with 5 cube roots of 5. So really we can just add and subtract our like radicals when the index is the same and the radicand is the same. All right, let's hop into a couple examples here. Number 1, we're looking for like radicals. Okay, again, we see that square root of 2 and square root of 2. We know we can assume that index is a 2 since it's a square root, since we don't see a number. So let's go ahead and just combine those. If we have 3 square roots of 2 and 10 square roots of 2, we're going to end up with 13 square root 2. And then we have that radical 6. Well, we don't have any other radical 6's, so we're just going to subtract a radical 6. Okay, and that's our simplified expression. All right, number 2, now we don't see any like terms. We don't see any like radicals there. So what we want to try to do is work with that square root of 63 and rewrite it using our multiplication property of radicals so we can get a square root of 7. So if we think about that square root of 63, if we rewrite that 63 as 7 times a number, okay, so we're just going to work with this right side here. If we rewrite that as 6 square roots of, we know we want a 7, and then 7 times 9 is going to be 63. All we did, this right here and this right here, these are equivalent. Okay, we just rewrote that right side. Now if we keep working with that, we can use our multiplication property and split that radical up. So we can rewrite it as square root of 7 times square root of 9. Now all these are being multiplied together, so we're still just working with this right side. Now we know what the square root of 9 is. The square root of 9 is 3, so again if we rewrite that and we're multiplying times 3, now since we're multiplying we can still switch them up. It's commutative. We can move the order. We can switch around the numbers. So if we rewrite it one more time, we can have 6 times 3, which we know is 18, square root of 7. Okay, we're almost done. Now let's work back with that left side. We have 4 square root of 7 minus 18 square root of 7. We have the same radicand, same index, so we can combine, subtract our like terms. So 4 minus 18 is negative 14 square root 7. Okay, and we have our simplified answer there. All right, number 3. We have the same index. Our index is 3. We have our same radicand. Our radicand is 5x. So let's just subtract like terms. 4 minus 11, we get a negative 7. And we have our cube root of 5x. Okay, so the core concept there is we can just add and subtract our like terms when we have the same index and the same radicand. All right, last set of examples here. Now we're multiplying, we're distributing that square root of 5 through to those parentheses. Okay, so what we're going to do first is we're going to distribute. All right, so when we do that, if we write this out, we have the square root of 5 times the square root of 3 minus the square root of 5 times the square root of 75. Okay, now let's use our multiplication property with radicals. If we have the square root of 5 times the square root of 3, we know that's the same as the square root of 5 times 3. Minus, if we have the square root of 5 times the square root of 75, we know that's the same as the square root of 5 times 75. Okay, now let's keep rewriting it. We now have the square root of 15 minus the square root. You might need to use a calculator. If we multiply those together, we're going to get 375. Now, keep in mind, we're trying to simplify these. We want to try to get like radicals. Okay, we have a square root of 15 and a square root of 375. Let's try to rewrite this so we can have a radical 15 on the right side here. We want a radicand of 15 underneath there. So let's think. Can we rewrite 375 as 15 times some number? Okay, so if we were to use a calculator, we'd divide 375 by 15, and we would end up with a 25. Okay, we're getting close. We still have that left side of square root of 15. Now, using that multiplication property, we can rewrite the right side as square root of 15 times square root of 25. Now, we know what the square root of 25 is. Okay, that's our perfect square. That's going to be 5. So when we take the square root of 25, we have 5. Let's go ahead and write that out front of the 15. Again, remember it's multiplication, so we can switch the numbers around. And we have a 15 square root of 15 minus this. Now we have our like terms. We have our like radicand. We have our like index. This is the same as kind of 1 times that. So if we have 1 square root of 15 and we take away 5 of them, we're going to end up with a negative 4 radical 15. And this is our answer. This is our simplified form. We had to keep working until we got like radicals. All right, let's do our last example here. Now we have what we see. This is a binomial. There's 2 terms there, and it's a binomial squared. So if we remember, if we rewrite that out, squared just means basically the same thing multiplied twice. So we have 2 square roots of 5 times 2 square roots of 5 minus 4. We're just basically doing it twice. Okay, think back to chapter 8. Think back to our last chapter. When we are multiplying binomials, we're going to use the box method. Okay, that actually didn't go away. Like it or not, it's still here. So we're going to make our box. Remember, first term right here, 2 square root of 5, and we have a minus 4. 2 square root of 5, and a minus 4. Now remember, inside we're multiplying. Ooh, we haven't done this before. Let's see. We have 2 square root of 5 times 2 square root of 5. Really what we're doing is all of these are being multiplied together. So if we want to switch around the order, we can. We can do 2 times 2, which is 4. And then we have radical 5 times radical 5. Okay, we can do this one of 2 ways. There is a shortcut, but let's go ahead and approach it the long way to start. If we use our multiplication property, we know that's the same as the square root of 5 times 5, which is the square root of 25. We still have that times 4 out here. And we know the square root of 25 is 5. So really in the end we get 4 times 5, which is 20. Okay, so that's what we get in our first box. We have a 20 here. All right, the radicals actually disappeared. Now this shortcut that we'll kind of work with, and we'll see it'll work out a little better in the future. When we have 2 radicands that are the same and we're multiplying the radicals together, square root of 5 times square root of 5, we can just drop the radical and we know it's going to be 5. If it was square root of 10 times square root of 10, we can drop the radical, it's just going to be 10. Square root of 8 times square root of 8, drop the radical, it's just going to be 8. Okay, and that's a shortcut we'll use in the future. Now multiply the outside. If we have negative 4 times 2 square root of 5, we're back in our box here. We're going to have negative 8 because we're multiplying negative 4 and 2. Negative 8 square root of 5. Now if we have that in that box, negative 4 times 2 again is negative 8 square root of 5. In our last box, 2 negatives give us a positive when we're multiplying. And then if we think back to chapter 8 again, we finish this up. Okay, what we have is 20 plus 16. We're combining like terms. We get a 36 there. Negative plus a negative is a negative 16 square root of 5. Notice we have like radicals there. Square root of 5, square root of 5. They're both negative 8s. Negative 8 plus negative 8 is negative 16. And we have our simplified answer. All right. All right, now that we've finished up, go ahead and turn in your student journal to page 280. We listed out these 4 problems in case you don't have your student journal with you. Numbers 22, 23, 25, and 26. Go ahead and finish these 4 up for tomorrow, and we'll look at them in class. Have a great rest of your night. Thank you for watching.